Hi, this is Ronald Adolph and welcome to Spring Core Framework with Spring Tool Suite. Spring Core is an application framework and inversion of control container. It offers comprehensive infrastructure support for developing robust Java applications quickly while conforming to common design patterns. In this course, we're going to cover relevant topics working with Spring, such as dependency injection, inversion of control container, constructor and setter injection, auto wiring, various forms of configuration, the Bean lifecycle, aware interfaces, aspect-oriented programming, and more. But before we get started, there are a few things you do need to know, so let's get that out the way first. Before you get started with this course, you'll want to have a basic understanding of Java and object-oriented programming in general. In addition, you'll want to deeply understand what dependency injection is. Now, I'm going to cover that topic, and I'll definitely give some examples, but this is a concept that runs so deep that, for me personally, I found it very useful to review multiple sources explaining this topic for me to really understand it instead of just following one. And I recommend this approach for any type of topic that can get very complicated. Never just go by one source, but by many. And in this way, you will be able to, in a strong position, be able to explain it with your own voice. Next, make sure that you have the JDK environment installed on your computer, in addition to an IDE such as Spring Tool Suite, which is what we're going to be using and what I highly recommend. But you could also use Eclipse, which is what Spring Tool Suite, also known as STS for short, is based off. Now, if you have another IDE you want to use that you really like, you can, that you could develop Java applications on, but I strongly recommend just using what we're using so that you could just easily follow along. If you were to go to Spring's homepage to learn what Spring is, it might seem a little overwhelming at first. And if you clicked on Why Spring, you get this general explanation. Spring makes programming Java quicker, easier, and safer for everybody. Spring's focus on speed, simplicity, and productivity. This is not really an answer you would want to give if you were asked what Spring is in an interview. If you said something like this, they'd call security and escort you out the building. If we hop down over to Wikipedia, it has a more technical explanation saying that Spring Framework is an application framework and inversion of control container for the Java platform. Then it continues saying that the framework's core features can be used by any Java application, but there are extensions. And right over here, it already gets a little too convoluted, and it's not the way that you would want to word it if you were asked in an interview questions. Like when I go in my courses, I always like to think in terms of the real world of how you would want to explain something if asked in person. Now, there is good content to use as reference on this page, but if we're strictly talking about a technical explanation, after doing some research, this is how I would summarize it. And I should mention that when I mention Spring Core or Spring Core Framework, it's referring to the same thing, Spring Framework. And my explanation would be Spring Framework is an application framework and inversion control container. It offers comprehensive infrastructure support for developing robust Java applications quickly while conforming to common design patterns. Now that's my summary of what I've gathered, but I could simplify it even more to make it sound a little bit more like plain English. So if I were in an interview and they were asking me what's Spring Framework, I would say that it's a framework that essentially lets you build apps faster by providing you the plumbing that you don't need to write so that you could focus on business logic. And you could do all this while conforming to industry programming standards. That's a little bit more easier to remember, and it just sounds normal. Now, this is not to say that on Spring's website that they had no definition anywhere in there. If you actually Googled what is Spring Framework, you do find it eventually. And it's not even on the homepage. It's buried under projects. And they have their detailed explanation of what the Spring Framework is right here. But it's still a bit wordy, but at least It's something that should have been on the home page in a more simplified manner. I mention all of this to point out that sometimes it's important to look at multiple resources when learning a technology and coming up with your own simple definition. So we now know that Spring's purpose essentially is to make our lives as developers easier, but how specifically? Let's turn to some advantages that it brings to the table to accomplish this. So what are some of the advantageous benefits that Spring provides? Well, first and foremost, it's an inversion of control container that allows you to use dependency injection. And in short, this is all about the framework having the ability to manage objects, creating them on the fly as needed. And we'll learn more about that later on in the course. In addition, Spring allows you to implement aspect-oriented programming, or AOP for short. Spring AOP module provides what's referred to as interceptors to intercept an application. So for example, when a method is executed, you can add extra functionality like logging before or after the method execution. We'll dive deep into aspect-oriented programming later on. Another thing that Spring brings to the table is the ability to write applications leveraging the model view controller design pattern, which is one of the most popular design patterns in web development. Now, something that might be taken for granted is the fact that Spring is very lightweight. That's a really big thing because sometimes when you're building large-scale applications, if you have to have systems that are huge in order to just avoid being bogged down by the IDE or framework that you're using, it becomes a hassle, and it's not an issue with Spring. Now, if you're a fan of test-driven development, you'll be happy to know that built into Spring is the ability to unit test. It was designed in order to make testing easier, and the documentation is pretty straightforward that addresses unit testing, integration testing, and points you to some other resources that you can use. Another thing Spring brings to the table is transaction management. In general, Spring simplifies data access when working with databases, and transaction management is just one example. One of the coolest aspects that I like about Spring is that it's an open source community. And this is really great because whenever you're working on large scale projects, especially if you're working on a small team and you need to reach out to other people that might have done work that's similar to what you're doing, or if you come across hurdles, it's great to be able to have resources outside of your work environment that you can get in touch with. And because it's open source, we have some documentation here that lays out some areas that you could use to access other individuals, whether it be on GitHub or Stack Overflow, etc. Never underestimate the power of the open source community, and Spring made sure not to neglect that. As Spring became more popular and people began realizing the power that it brings to the table, projects began being developed, and eventually a whole ecosystem is now existing because of this. So if you look on this site here, under projects, you could see all these different projects that you can leverage to your own advantage in order to avoid rebuilding the wheel or creating tools that might already exist. Like if you were going to, for example, create an application that is going to be cloud-based using Spring, you can come over here and learn about Spring Cloud. If your application is going to be doing a lot of work with tons of data, maybe you want to leverage Spring Data. But the point is, because of all these projects, it's another way of simplifying the life as a developer when you're using Spring Framework. And I should mention, a lot of these projects and some of the benefits that I mentioned earlier, such as being able to build an application using WebMVC or testing, entire courses could be created on those topics. But in order to make the most of those topics or these projects that you see here, before tackling any of them, you'll want to be very familiar with some core Spring concepts and functionality, like the ones you see here, which we mentioned earlier, which is the purpose of this course. But before we get started, we need to set up our environment, so let's take care of that now. So as mentioned earlier, before we even get started with this course, we need to have the JDK installed on your system along with Spring Tool Suite. But once that's done, we can go ahead and launch Spring Tool Suite, and I'll sometimes refer to that as just STS. Upon launching it, it'll ask you to set your workspace, and I'm just going to go ahead and choose my default, which is in my Documents folder. I also created a folder called Dev under my Documents, and then Spring Tool Suite went ahead and saved the workspace directory. So I already did that. I'm just going to go ahead and click Launch. The workspace is going to be where all your projects are going to reside, and under the Dev folder is where I am going to have my Spring Framework installed. So I've already downloaded it here, but I'm going to go ahead and just trash it so that you can see me freshly download a later version of it. Now, in order to use the Spring Framework, there are a few ways to set it up in your project. One is manually by downloading the dependencies of Spring that you need to reference, and the other is by using a management tool. In this video, we're going to manually download the dependencies and reference it in our project that we're going to go ahead and create. This is the site that you want to download your Spring dependencies from, with the URL starting with repo.spring.io, and you can see the rest if you want to go ahead and copy it. Towards the bottom is the latest version of Spring, and it's a little tricky at first because you would think 5.39 is the latest because it's at the bottom here, but not really, because if you look up, you'll notice that 5.3, 10, 11, and 12 are actually newer versions, and 12 is the latest that we want. So I'm going to go ahead and choose that. That'll bring me to this location here, and what we want to do is download the file that ends with -dist.zip. Now I've downloaded it to my downloads folder. This is where I'm going to go ahead and extract it, and then I'll move this to my documents folder and push that up in my dev folder. Now to get started, we're going to first create a Java project. I'll click on this link here, and we'll call this manual jar demo. Click Finish. And our next step is to create a package. So I'll right click on my project, go to New, Package, and I'll call this com.spring. Click Finish. Now we want to create just a very simple class to execute a simple statement. And I'll call the class app. And we want to check here public static void main. So we have a starting point, and click Finish. So just to make sure that we have a project that's working, let's just print out a statement that says manual Spring setup demo, rise and shine. I'll save that and execute it. Java application, click OK, and it prints it out. All right, so now what we want to do is prove that there's not Spring set up yet, just so that we know that Spring is not in any way being referenced here. I put in an import statement to reference context within the Spring Framework, and as you can see, there's an error being thrown here because it doesn't know where it is. So this is an issue. The import org Spring Framework cannot be resolved. So what we need to do is reference it with the jar files that we just downloaded. And we do that by right-clicking on our project and going to Build Path, Configure Build Path. You'll want to make sure Libraries is chosen, that tab, and then select Class Path. And what do? We had downloaded some jar files, right? And now we want to add those. So let's add external jar files and navigate to our dev folder, which is where the Spring Framework is, and If we expand this under libs, that stands for library files. I mean, I'm assuming, I actually never really looked that up, but it seems kind of obvious. Highlight everything, click open, apply, and close. And now you'll notice that that red line is now gone. And instead, what it shows is a yellow line that indicates that this import statement is never being used. And on our left-hand side, under the Package Explorer, we can see all reference libraries related to Spring that we had highlighted. And just to make sure nothing broke, let's modify our statement here with just deleting a couple exclamation points, running it again, and boom, looks fine. So this is the manual version of setting up Spring by downloading the dependencies. But sometimes when you're working on huge applications, there might be times you need to change versions and you don't want to have to re-download dependencies. It can become a headache. It's good to have a tool that you can use that can simplify the process. And that's what we're going to show in our next video, setting up Spring with a management tool called Maven. So another approach to set up Spring is to use a build and dependency management tool called Maven. And Maven addresses two aspects of building software: how the software is built and its dependencies. We're going to be using it mainly for its features with handling dependencies. And one quick thing that I want to show you is this website here that's similar to the repository that we saw before, except this one's designed for Maven so that you could specify the type of dependency that you want. So we could enter in here in the search box for this Maven repository, Spring, and it'll point you to the dependencies that you can just download the configuration text for. So for example, we're going to want to use Spring Core. If I click here, now I can see all the different versions of Spring. This one is organized a little bit better. It shows the latest version at the top, 5.3.12. And if you recall from the last directory that we were looking at, 5.312 was the latest that was available. Except in this case, when we click on this link, all we're going to care to copy is this XML text here that points to the version and the name of the dependency that we want. So we're going to end up copying this text here and also Spring context. So if I've already copied this and have this set aside, but I just wanted to show you exactly where I got the node from. So how do we use this? Well, let's hop back to Spring Tool Suite. And what we're going to do now is create a new project, except it's a Maven project. So it's not showing up in our menu here. So if we click on Other, you could just navigate down to the Maven folder and choose Maven Project, or this is just for future reference, but you can always type in the name of the project that you want. So if I had typed in Maven up here, it automatically filters it down. I can choose Maven Project and select Next. At this point here, I'll just keep the defaults and move on to Next. And here it shows us archetypes to select. And these are essentially templates of Maven projects. And we just want the default. If this is not the default for you, the archetype Quick Start, go ahead and select it. Just look for it and select it. You'll notice that the catalog is internal. You can actually choose to see all catalogs where it'll show you a lot more. If for some reason you have issues finding it, make sure that you have internal selected just so that you could just jump right to Quick Start. So click that, choose Next. Our group ID, I will leave that as Spring, but for artifact ID, I'll call this Maven Demo. Our artifact ID is essentially our project name, and the group ID is the package name. And you'll notice that the group ID is a combination of rephrase, and you'll notice that the package on this line right here is a combination of the group ID and the artifact ID. So we'll click Finish here, and when we expand our Maven project, if we navigate to source main Java, under our package, you'll see that there's a default app class with the statement of print out hello world. I'll go ahead and just change that to Maven Spring Setup Demo. And just like our previous project, we're going to put an import statement that references the Spring framework, specifically context, and it too is now complaining. So what we want to do, instead of having to actually download files manually, we can go to our POM file. This is a configuration file that you can use to specify the dependencies that you want. So as you can see here, JUnit is in here mentioned as a default. And as I mentioned earlier, I copied the nodes for the dependencies that we want. So I'm going to paste that in now, which is Spring Context and Spring Core. We'll save that. And towards the bottom, it happened pretty quick, but it immediately started downloading the dependencies for Maven. And actually, because I did this before, it might have cached it. So on your end, you should see at the bottom right-hand corner some image that represents that it's been downloading. And then after a few seconds, you'll notice that your Maven dependencies are here. And now, if we were to jump back to our app file, we no longer have our error, and we can choose whatever we want in terms of like referencing the classes within the Spring Framework. So initially I was referencing within the Spring Framework context and also core. Well, what exactly is context? In our next video, we're going to go ahead and explain that because it's an important concept to understand before we do anything else further when using Spring. Now, in our last video, I mentioned I wanted to discuss the application context. But before we do, we need to discuss what an IOC container is. IOC stands for Inversion of Control, and the Spring IOC container is the core of the Spring framework. It's this container that is responsible for creating objects, wiring them together, configures them, and manages their complete life cycle from creation to destruction. And the manner in which it does this is through a process called dependency injection to manage the components that make up the application. How does it do this? Well, it receives instructions for which objects to instantiate, configure, and assemble by reading the configuration metadata provided. And that configuration can be either pulled from an XML file, Java annotations, or Java code. Now, there are two types of IOC containers in Spring. One is called the Bean Factory, and the other, what we mentioned earlier, is called the application context. The Bean Factory, first thing that you need to know, and the main thing that you need to know, is that it's an interface. And if you're familiar with design pattern, well, the Bean Factory kind of functions like a factory class that contains a collection of beans, otherwise known as objects, and it instantiates those beans whenever it's asked by a client. Now, the application context is also an interface just like the Bean Factory. In fact, it's built on top of the Bean Factory interface, and it provides additional functionality. So what's like the main difference between these two? The thing to know is that the application context comes with advanced features, including several that are geared towards enterprise applications, while the Bean Factory comes with only basic features. So therefore, it's generally recommended to use the application context, and we should just use the Bean Factory only when memory consumption is an issue. Now, the benefits of using an IOC container includes minimizing the amount of code that you need to write. It also promotes and facilitates the process of loose coupling your code, and as a result, that makes your code easier to test. And it also supports lazy loading of services, so those services would not get called until they are absolutely needed. Now, we mentioned dependency injection a few minutes ago, and it is essentially the process where the Spring Framework looks for beans, identifies their dependencies, and creates the instances of the beans that are needed. And again, beans are objects. In dependency injection, you don't need to do that work of creating any of these objects, and you don't need to connect your components and services together. Rather, you just describe which services are needed by which components in a configuration file, and the IOC container will wire them up together. Now, this all might sound overwhelming at first, but it's all going to start coming together through an example so you can see how a configuration file comes into play, what I mean by having Spring automatically create an instance of objects for you, and referencing the application context. So why don't we go ahead and set up an app and demonstrate what we're talking about. That's up next. In our demo, we're going to be building a small app that can simulate using multiple phones, specifically either an iPhone or a Galaxy. Now we'll first set it up where we can create instances of the phones in our app, but later modify the code to show how Spring can create those objects for us using dependency injection. This is going to involve using what we mentioned before, such as the application context and setting up a configuration file. So let's go ahead and get started by creating a new Maven project. We'll choose the defaults here. Make sure that the archetype is quick start. And the group ID will be com.spring.ioc. We'll have the artifact as dependency injection. And click finish. Next, let's go ahead and add the dependencies that we want in our POM file. And just as we did before, we're going to want the Spring context, Spring core. I'll close this. And now navigate to our package location under dependency injection. And then we're going to create an interface called phone. On our phone, there's going to be two things we're going to care about doing. We're going to be able to call on it. So let's add calling as a method stub, and then also browsing the internet. And that's essentially using data. So we'll say data. Now we want to add our implementation class. So the first one will be an iPhone. So let's create a class, call this iPhone. And it will implement phone. And if we hover right over here, we'll go ahead and add our unimplemented methods. Now we'll write out a statement that just says calling using iPhone. And right below, we'll write out browsing internet using iPhone. Okay, looks good. So we're going to want to do the same thing for Galaxy. So let's copy and paste this. We'll change this to Galaxy and just change the verbiage. Calling using Galaxy, browsing internet using Galaxy. Next thing that we want to do is actually create the code to use it. So what we'll want to do is get rid of this hello world statement here. And we're going to create an instance of the phone that we want to use. So let's say we want to do it with the iPhone. Now using the interface phone, we're specifying specifically that we're going to create an instance of the iPhone. And now we can invoke our methods such as calling and data to demonstrate browsing the internet. And if we want to test this now, we can run it, calling using iPhone and browsing internet using iPhone. All right, perfect. So if we wanted to do this with the Galaxy, what we need to do is in our source code here of this app file, we want to just change this to Galaxy, right? Save it, run it, make sure that it works. It does. So a couple of things is happening here. The first thing is that we are modifying our source code, the code that would need to be built if there's any changes to it. Sometimes we want to avoid having to do that, and a way to do that is to have a configuration file to specify your changes, and that could be done with an XML file. The other thing that's happening here on line 5 is that we're creating an instance of Galaxy or iPhone, and in our situation here, what we want to do is have Spring do this for us. So instead, we'll specify in our configuration file the objects that Spring needs to create, and then it'll know when to create an instance of that object, aka bean. All right. Later on in this course, we'll be referring to these objects as beans because that's the term that's usually used when we're referring to the Spring framework. So let's go ahead and show in the next video how we can have Spring do this work for us. Now, the first step in getting Spring to manage our beans is first, let's go ahead and comment out these lines that we have here, lines 5 through 7, and we'll begin using the application context. We'll define the context, and the way that we use it, I'll come over here and make sure we import it, is by instantiating its implementation class, which is called class path XML application context. And within here, we'll pass in the location of an XML file that we'll create. And we'll call it appconfig.xml. We'll also want to import this class path XML application context. Next thing we'll want to do is create that XML in our class path. So if we right click on source main Java, we'll create new and search for XML, choose next, and we'll give it the name that we specified, app-config, and there we go. Now within this XML file, in order to be able to define our beans, we'll need to specify the location of the XSD. Now you might be asking, how would you know how to specify this XSD location? The files that we downloaded for Spring earlier, if you looked under the Spring Framework folder, whatever version it is that you're using, under docs, reference, HTML, there's this core.html file that you can open up, and this is where I basically copied and paste the location of the XSD. So if I were to go to my directory, you see the core.html file right here, and at the bottom of the screen you can see the path that I followed from the Spring folder to docs, reference, HTML, and core. And all I did is just launch this file. The next thing is to define a bean. So in order to do that, what we first need to do is give the bean an ID. And let's say that we first start off with iPhone. Next, we'll need to specify the class itself. And what we need to do here is put in the fully qualified path for that iPhone. So if I come here, right click, copy qualified name, hop back over here and paste, and that'll write it out for you. Now if we hop back to our iPhone class, just to show that this class actually gets called, I'm going to go ahead and create a constructor with a print statement within it. iPhone constructor called. And right over here, if nothing goes wrong, we should print out that the configuration file was loaded. And this right here is actually misspelled. It should say app-config. So let's run it, and it looked like it worked as expected. iPhone constructor was called and config loaded, so nothing crashed, which means that it actually saw our app-config XML, loaded the beans that was specified in it, and went on to line 13 to print out config was loaded. So at this point, let me go ahead and get rid of the constructor. We don't need that anymore. We'll hop back to our main method. I'll comment this line out. And what we'll want to do is define a phone and use our context to get bean. This is how we actually call the bean that we defined in our XML file. And within here, we'll want to pass in the ID of the bean. And we'll want to indicate the phone class. And the following lines is pretty much the same that we had earlier. So let me just copy and paste this. And now when we run this, we see that we're calling using the iPhone and browsing the internet using the iPhone. So this bean was created and managed in the background by Spring through the use of dependency injection. But what we could do is really indicate that this is just phone, because by indicating phone over here, it can be either the iPhone or the Galaxy. And that's where it allows us to have our flexibility, because we can come over here, specify this ID to just be phone. And if we wanted to change this to Galaxy, now we're only changing the XML. And when we save this and run, it will indicate that it's calling using Galaxy and it's browsing the internet using Galaxy. And if we wanted to just switch that back to iPhone, save that. All we did is just change the XML. Actually, I need to specify this is as a capital letter, iPhone. And boom, there you go, calling using the iPhone. Now, as you could see, there was just like an error that I had made where I specified the wrong syntax for iPhone, right? So while XML using this has the advantage of allowing us to change some of our configurations without having to compile, the thing that we lose is the strong typing, the ability to detect errors in syntax that we would normally catch when we're writing in Java code. That's not happening in XML. So sometimes it becomes useful to just apply this configuration within Java, and you can do that with Spring, and I'll show you how to do that next. Java-based configuration option enables you to write most of your Spring configuration without XML, but with the help of a few Java-based annotations. There's a couple that we're going to mention. The first includes @configuration, which indicates that the class can be used by the Spring IOC container as a source of bean definitions. The second, which is the bean annotation, tells Spring that a method annotated with @bean will return an object that should be registered as a bean in the Spring application context. So let's go ahead and do a demonstration by converting one of our existing apps that currently uses XML configuration to use Java-based configuration. And what we'll do is copy the dependency injection app and save that as for_di_java config. So all I did is copy and then hit Control V to paste, and it prompted me this dialog box in order to enter in the new name. And I'm typing in this name, but I'm going to go ahead and rename the previous projects just to clean up so we can easily find the projects that we're working on. And the way I'll do that is by going to right-clicking on dependency injection. That's our existing XML configured app, and we will refactor, hit rename, and let's give this a name starting with the module/chapter that we're on, DI, and this we will call XML config. And for the remaining projects, Those were in the previous section. So let's go ahead and just add an underscore, the number 3 and an underscore, and leave the name as is. Refactor, rename, 3 underscore. And just to show that this really didn't break our code, I'm going to go into our Java config, which is still really our XML configuration file, and we'll just highlight our app, run it just to show that it still works without having been broken, and it does. So the first thing that we're going to want to do is get rid of our XML config file, and instead of deleting it, I'm just going to rename it. I always like to just rename things and save deleting to the very last step when you know you absolutely don't need it, because you never know when you need to revert to something. So I'm going to change this to archive underscore app dash config. Now if we try to run our app, we'll see that it crashes because it can't find app-config.xml. So when we have a project that is configured through Java, we want to have a Java class. So let's go ahead and create that, which is going to have our configuration information. And we'll call this app config. Within this app config, we're going to want to return our objects, and we could disguise those as services. So let's create a method called Galaxy Service that's going to return our Galaxy object. Return new Galaxy. And we're going to want to repeat the same thing for our iPhone. iPhone is being returned, and it's called iPhone Service. Now remember, there was an issue when we had the XML file and I had a typo in there because I had the wrong syntax for iPhone. Well, if we're doing this in Java, if I accidentally typed in a smaller case, we see that it automatically gives me a heads up that there's an issue there because the IntelliSense picks it up. And that's one of the benefits of using Java. So let's fix that back to iPhone with a capital I. And the next thing that we're going to want to do is use the annotations that we mentioned at the top of our class at configuration. And as I mentioned, that is going to indicate that the class could be used by the Spring IOC container as a source of bean definitions. And the next thing is to add at bean, which will return an object that should be registered as a bean in the Spring application context. Now these are complaining because we need to have some imports that are missing. The first is for annotation.configuration, and the second annotation.bean. So our method name is annotated with @bean, which works as a bean ID, and it creates and returns the actual bean. So it's equivalent to the bean ID that we have here in our XML file. And as you can see, our configuration class can have a declaration of more than one bean. Now, once this configuration class is defined, you could load and provide them to the Spring container using annotation config application context. And we do that over here. Let's go back to our app, to our main app class. We'll clean up these commented code here and get rid of them. I'll comment this out, but what we're going to add is annotation config application context. Let's add our imports that we need. CTX for context, and we're going to create a new instance of annotation config application context. And now what we need to do is register by adding our configuration class that we just created, app config.class. And the next thing to do is invoke refresh. And that just loads or refreshes the persistent representation of the configuration. And for the last 3 lines, all we need to do is just remove phone and put in the class that we want to execute. So let's say for Galaxy, enter that, save and execute, and there you go. Calling using Galaxy, browsing internet using Galaxy. And if we change this to iPhone, we got this error here. And let's look back at our app config. Well, that would make sense because we didn't add @bean. And so now if we go back and run it, it shows calling using iPhone, browsing internet using iPhone, and we're not using any XML configuration. Now, besides using Java-based configuration, there is a term called annotation-based configuration. So let's go ahead and take a look at that next. Now, we just talked about Java-based configurations, which uses a couple of annotations, but there's actually the term annotation-based configuration, which usually refers to a few more annotations, including the following: required, auto-wired, qualifier, and JSR 250 annotations, which involve resource, pre-destroy, and post-construct. Now, required is applicable to Bean property setter methods, but it is deprecated. We're not going to be covering that in this video. Auto-wired is mainly applied to Bean property setter methods, constructors, non-setter methods, and properties, and essentially provides more control over where and how auto-wiring should be accomplished. Now, qualifier, this annotation, along with auto-wired, is used for removing the confusion by specifying the exact bean to wire. Sometimes Spring might be confused about which bean to wire, and this is the term you can use to rectify that problem. Now, JSR 250 annotations are generally supported by Spring Framework, including resource, pre-destroy, and post-construct, but they're often not required since there are alternatives to do the work that these provide. So we won't be covering those in this video. Now, when working with these annotations, you can apply the Bean configuration into the component class itself by using annotations on the relevant class, method, or field declaration. Annotation injection is, and by the way, I mentioned annotation injection because keep in mind, these configurations are the different ways in which Spring can perform dependency injection. So annotation injection is performed before XML injection. So in other words, the latter configuration will override the former for properties wired through both approaches. So you can have XML configuration along with annotation configuration. You can use them interchangeably, and you can have them both, but XML will take precedence. So you can have some type of definition specified with annotations, but if you also have the same in XML but specifying something different, what's in the XML is going to take precedence. Last thing to point out is that annotation wiring is not turned on in Spring by default, so we need to actually enable it in our configuration file. Let's go ahead and take a look at some examples so you know exactly what I'm talking about. The first project that I'd like to demonstrate is for auto wiring, and you could find that under for_di annotation config AW. Now when we expand this, if we hop on over to the app config XML, I want to show you where we are enabling annotation configuration, and that's on line 11. Below that, you can see that we have a text editor, Bean definition, and a spell checker that is commented out. This app itself just simulates having a text editor that has a spell checking feature. If we go to the app file, we'll see on line 8, we use context, the new instance of class path XML application context to point to the XML file. And right below that, we actually get the bean called text editor, and then we invoke on line 10 the spell check method. Within spell check, you'll see that in that class, there's a constructor that's just going to print out inside spell checker constructor. And right below that is a regular method called check spelling, and that's just going to write out inside check spelling. In our text editor, on line 6, we have a private variable for spell checker that we later assign the value of spell checker to it in the method set spell checker, which accepts a parameter of spell checker. A lot of spell checkers in there. On line 13, we have our method getSpellChecker where we return the object spell checker, and on line 17 we have our method spellcheck where right below on 18 we see that I create an instance of spellchecker, and then after I assign that new object to spellchecker I invoke check spelling. So if we run this, it'll print out the two statements. The first when it was inside this constructor, and then when it invoked the check spelling method. What we want to do is comment out line 18, because I don't want to manually create this instance. I want Spring to do that. And the way we can do it is by having used the auto-wired annotation on line 8. So I'll uncomment that. And that's not going to be enough for Spring. We need to specify that being in our XML. So I will uncomment line 16. And in fact, before I even uncomment it, why don't we just run it so we could see the error that happens. Error creating bean with name text editor. If we scroll all the way down, we could see there is no qualifying bean of type spell checker. So now let's allow that bean to be defined in our XML, save that, and when we run, it will work as expected because now Spring itself is doing the auto wiring because we're specifying it on line 8 and we define that bean in our XML. Now in our next example, we're going to demonstrate the qualifier annotation. So in this project here, ending with annotation config _q. Let's open up the XML configuration file first. Again, you'll see on line 11, we enable annotation configuration. And here we have a few bean definitions. The first is for profile, and we're going to have two profiles, employee 1 and employee 2. One is named Ray, that's age 21, and the other one is named Sky, age 22. If we go to our app file, once again on line 8 we reference our XML file, and then following that on line 9 we get the bean profile, and then we invoke the methods to print the name and age. So if we go into our employee file, we simply see the variables for age and name and the getters and setters for both of them. And in our profile file, I'm going to go ahead and comment out qualifier here, and we're going to see what happens when we try to execute this. As you could see on line 11, there's just a constructor that's going to print inside profile constructor, and right below that it's just going to write out the age and name when the methods print age and print name are called. Let's go ahead and run this, and let's see what happens. Big error here. I can copy and paste this in a text pad, and let's maximize to see what's here. Right over here it says no unique bean definition exception. It expected a single matching bean but found two, employee 1 and employee 2. So this is an example of where Spring gets confused. It's like, hey, which bean do you want me to choose, employee 1 or 2? You got to be more specific. And this is where we could use our annotation qualifier. Okay, Spring, we want you to specifically choose employee 1. I'll save that, run it, and there you go. Inside profile constructor, age 21, Ray. Nothing crashed. No issue this time. In our last video, we demonstrated annotation-based configuration, and the way we enabled it was using annotation-config. within our config file. Now, another approach to activate annotations is using component scan. So what's the difference? Well, with annotation config, it mainly is used to activate the dependency injection annotations mentioned earlier, which include auto-wired, qualifier, post-construct, pre-destroy, and resource. However, component scan, which also recognizes and processes dependency injection annotations, can resolve what annotation-config does not detect, and it does it by component scanning. And when it does the component scanning, it needs to use the base package attribute to specify where to find them. That is, it tells Springs which packages it needs by scanning to look for the annotated beans or components. And they will include component, repository, service, controller, Rust controller, and configuration. To get a better idea what I'm talking about, let's look at an example. Okay, so to get started, let's go to one of our projects to duplicate, and we'll choose the XML config project. So let's copy that and paste, and we will save this name as annotation config underscore comp for component. Let's execute the project, make sure that it works, and it does. So let's hop over to our app config file. And what we're going to implement, we're not going to need to define the bean here. So I'm going to go ahead and comment this out. If I were to run it again, we should get an error that it does not find a bean. No bean named phone available. Perfect. Now, before we could use component scan, we want to update our XML namespace, basically the XSDs. So I'm going to go ahead and paste an updated version. And basically, this is almost identical to what we had before, except there's 3 lines that's added. Line 5, line 8, and line 9. And if you were to go into the documentation that we looked into earlier, you can copy and paste it yourself from section 1.10.3 under automatically detecting classes and registering bean definitions. At this point, we could add component scan, and we need to specify our base package, very important, which is going to be com.spring.ilc.dependency injection. Now, all we need to do is go to our iPhone class, and we want to set it up as a component. And to do it, all we need to add is our add component annotation. Whenever we use a stereotype annotation like this, we don't need to specify it in XML as a bean definition, because having this add component on top of iPhone is essentially the equivalent of having what we had on line 11, this bean definition. But notice on line 11, we did specify that the ID is equal to phone. Well, we didn't do that over here in our class. Well, what Spring does is it takes the class name by default and assumes that this is going to be the name that we need to use. And usually it will take that name and put it all in lowercase, and that's what we need to use to call it. But in my case right here, because I'm using 2 capital letters, IP, for some reason it just assumes that it's going to keep that same syntax and not put in lowercase. So in short, if we go to our app, when we need to call it, where we usually had phone, I will now just put iPhone. And I did not put it all in lowercase. You'll see when I have to do that in our next example. But let's clean this up here, get rid of these comments here, and execute and see if it works. And it does. Calling using iPhone, browsing internet using iPhone. So having kept the case just like this works perfectly. If I changed it both to lowercase, it would not work. And let me just show you that real quick. You see, it crashes. So we leave it as iPhone. However, if we were to change this to Galaxy, we want to have it as lowercase, because with Galaxy, Like most classes, just the first letter is capitalized. That's the normal convention. So it's going to assume that the name is going to be Galaxy with all lowercase. And I need to add component. If I don't, actually, let me just run the app and show you that it's going to crash. No being named Galaxy. What we need to do is add component, add our imports. And now when we run it, calling using Galaxy, browsing internet using Galaxy. So Spring was able to eliminate the need to have a bean definition just because we were able to use component scanning, and the framework itself knows to treat this as a bean definition for both Galaxy and iPhone. And we did this using component scan. A good article that I found that explained the difference between annotation config and component scan is right over here. So you may want to take note of it. When it comes to dependency injection, there are two specific types I'd like to cover: constructor-based injection and setter-based injection. Now for constructor-based injection, it's basically when a container calls the constructor of a class, and it should be used for mandatory dependencies. So let's say that class X is tightly dependent on class Y, then we should definitely use constructor-based injection. Now for setter-based injection, it can be used by calling the setter methods of your beans, and it generally can be used for optional dependencies. Let's start off with a demo for constructor injection. So to get started, let's go ahead and create a new project by basically duplicating, and we'll choose the annotation config _AW project. So I'll copy and paste that. We will save it under the name of 5_di constructor. And within our source folder, let's go ahead and delete spell checker and text editor just so we could get somewhat of a clean start. We're going to recreate those classes. Let's take a look at what's in our app class. All right, so it's complaining about text editor. So let's go ahead and create that class now. Text editor. And we're going to want to include a constructor in there. So let's check this box right here. We'll also want to create our class for spell checker. Make sure that it includes a constructor. We'll go back to text editor, and we'll start off by defining a private variable for spell checker. And right over here within the constructor, this is where we are going to pass in spell checker. And then we'll enter a statement that assigns spell checker to this dot spell checker. And right above here, I'll write out a statement that says inside text editor constructor, so we know where we're at when we're executing our program. Now if we hop over to our app, we see that it's complaining about spell check method. It's not there, so we'll go ahead and create that. That brings us back to our text editor, and now it added our spell check method. And right over here, this is where we'll invoke spell checking, check spelling that is, which doesn't exist yet, but we'll create that method. And that brings us right into our spell checker class with a new method in there. Now within our spell checker constructor, let's go ahead and just write out a statement that we are in that constructor. And likewise for the check spelling method, we'll print out a statement stating that we're in that method too. So at this point, if I save everything, our app file should stop complaining, and it does, except for one little notification here. If we highlight over that, it says resource leak context is never closed. So let's just try and add a try finally block, add that in here in order to have access to our close method that we want to invoke. Let's explicitly specify class path. Now I can invoke close on our context. And that looks good. Let's hop over to our app config. Things look good here. One thing we'll want to do, a couple of things we'll want to do is we can comment out our enabling of the annotations here. And for our text editor, we'll want to explicitly specify our constructor argument. In general, this ref attribute is used to assign object type value to a variable. And this ref attribute should refer the ID value of another bean in the Spring configuration file. And in this case, it's spell checker for us. So I'm about to run this. Let's make sure that we are definitely working with the right project. I'll add 3 periods here. And on app, let's execute this now and make sure that everything works as expected. And it does. So in short, the main thing that we did here is demonstrated constructor dependency injection by passing in spell checker to the constructor of text editor. And the Spring framework noticed it and said, okay, I see that you're passing in this object here. I'm going to go ahead and create instances of it so that you could go ahead and complete your work. Next up, let's demonstrate how to do it with a setter. Setter injection is one of the standard ways of resolving dependency injection with Spring, which uses the setter methods to resolve the dependencies. So let's go ahead and take a look at how. Let's highlight the last project that we created. We'll copy, paste that, save this as di_setter. And within here, we'll go straight to our text editor class, and we're going to comment out our constructor where we're passing in spell checker. We're not going to be using this. We'll get rid of it. And we're going to want to create getters and setters. So with Spring Tool Suite, we can right click on spell checker, go to source, and create generate getters and setters. We'll check spell checker, click generate, and there we go. We have our getter method here that will return our spell checker. And then we have our setter method that's going to inject the dependency. And inside here, we can write out inside set spell checker. So instead of passing it into a constructor, we're passing spell checker into our setter. In our spell checker, we're going to keep things as it is, nothing to change here. Where we do have another change to make is in our config file, where instead of specifying a constructor argument for our text editor bean, we're going to be specifying a property with the name of spell checker using the ref attribute, assigning it spell checker. So let's go to our spell checker here. Instead of 3 dots, I'll just have 1 dot. We'll save everything and execute to make sure it works as expected. And it does. So we have some dependency injection going on, but this time it is using setter injection. So there you go. Whether you choose constructor or setter injection, the important thing to keep in mind is to always use constructor injection when there is a mandatory need for creating objects with all of your dependencies. And when that is not the case, then you can use setter injection. And some people feel that using setter injection is a little bit easier in terms of readability when you're dealing with a lot of properties and dependencies. So that's something to keep in mind if there's not a mandatory need of creating objects with all your dependencies. The life cycle of any object means when and how it is born, how it behaves throughout its life, and when and how it dies. So similarly, the bean life cycle refers to when and how the bean is instantiated, what action it performs until it lives, and when and how it is destroyed. There's a few high-level steps involved here. It starts off with instantiation, and then it moves on to populating properties. These are read from either property files or injected from other resources. Then the framework sets the bean name and makes it aware to other resources. At that point, we can set a bean factory aware context. Next, we do a pre-initialization using bean postprocessors. And from here, we can initialize the bean using the properties that were just set. It's at this point we can call an init method, which we're going to go ahead and do a small demonstration of. And then we wrap up the whole process using another set of bean postprocessors. Spring Framework provides the following 4 ways for controlling lifecycle events of a bean. They include initializing bean and disposable bean callback interfaces, aware interfaces for a specific behavior, custom init and destroy methods in bean configuration files, and last but not least, at post construct and at pre-destroy annotations. We're going to do a demonstration using post construct, which allows us to execute tasks right after work in the constructor is complete. Okay, so to get started, let's go ahead and we're going to copy and paste our project di_constructor. We'll give it the name 6_bean lifecycle. And within here, let's go straight to our spell checker class. And I want to comment out the constructor that we have in here for purposes that I'll demonstrate later on at the end of this exercise. Now, in order to use post-construct annotation, we're going to need an additional dependency. What we're going to want is JavaX annotations. So I'm going to copy and paste this from here. And again, this repository here is great. All I had to do is come in here and just search for JavaX, and then I found it right over here, JavaX annotations, and just chose the latest version, which brought us here. And from here, let's go straight to our app file, and right above line 12, I'm going to write out a statement. And my statement will be my main method statement. So here's the thing. What if I want something else to happen before line 11? That is, after our objects were created and tasks in their constructor were executed. This is where post-construct comes in, which makes sense. Post-construct. So if we were to go to our text editor, we can have a statement print out right after lines 8 and 9 are executed of this constructor by creating a public method, and we can call it init, and right above it add the annotation post construct, and make sure that we import our package, which is on line 3 now. So right over here on line 20, I can have the statement print out we are called after the constructor in editor. So we'll save that, and because we're using an annotation here in our config file, make sure that we have annotations enabled. We already have our necessary namespaces set up from previously here, specifically lines 5, 8, and 9. And now if we were to go and prepare to run the app, I ask you this. What are the sequence of statements that you're going to see? You see in spell checker, we know we're going to print out at some point inside spell checking. We'll see 2 statements here, one for inside text editor constructor, and then on line 21, we are called after the constructor in editor. And then on line 11, my main method statement. So go ahead and pause the video and think of the sequence in which the statements are going to be printed out. And now let's go ahead and run it. And if you had this sequence, congratulations. Inside text editor is printed first. Why? Because the first thing that happens here is Spring sets up our objects. And in that process, it also executes tasks that are within its constructors. And in text editor, we have our constructor, which includes the line inside text editor constructor. Then, as we discussed in terms of post construct, whenever the work in the constructors are completed, line 21 will get executed. So that's what's done next. Afterwards, my method statement is printed. That's on line 11 of our app file. And last but not least, on line 13, when we invoke spell check, that brings us to line 10 within our spell checker class, which prints out inside check spelling. So If I were to uncomment this, that is to add the constructor of spell checker inside spell checker constructor, if I were to rerun this again, where will this statement be printed in the sequence of all these other statements? Go ahead, pause the video, write it out, and then continue to see. If this was your result, congratulations. Both the lines in the constructors of spell checker and text editor are going to be executed first. So all tasks within all constructors of different objects are going to be done first before our third line, we are called after the constructor in editor, is executed. And then, as before, my main method statement is printed, and last but not least, inside check spelling. The more you work with Spring, the more you'll get familiar with the life cycle, but it's also good to look at various types of documentation, because I'm not a fan of the actual Spring official documentation just because of the way that it's organized, but I do reference it in conjunction with other references. This was a nice article that I found here on how to do in Java, which has a nice summary of the life cycle, but a good chart visualization also, and discusses customizing the Bean life cycle and some additional information you may want to check out that's a little bit more in detail. One word of caution: whenever you do research on the internet, you always want to cross-reference not only between the official documentation and whatever website that you're comparing, but at least 3 different sources. And pay careful attention when you're reading the information that was written in whatever article. Keep in mind how professional it's written. If there's typos in there, it could be questionable material. So it's always good to cross-reference for whatever topic that you are researching. As engineers, we're always learning, we're always researching constantly, so we need to get good at cross-referencing. Spring-aware interfaces allow you to hook into the inner workings of the Spring framework. Now, through these interfaces, you can actually access the Spring context or Spring Bean lifecycle events. For example, in the Bean lifecycle, the Spring framework can call some aware interface methods after populating Bean properties and just before pre-initialization with Bean post processor. Just as you see here, we have Bean name aware and Bean factory aware. And in fact, there's a lot more interfaces that are available to use, and you can see them on this site here. And right on our right-hand side, we can see Bean name aware. I know it's not very pretty, but it's a quick way to get a reference of these interfaces, like by clicking on here, and we can scroll down to get a decent definition of what the purpose of that interface is. And in this particular case, the description is interface to be implemented by beans that want to be aware of their bean name in a bean factory. Let's go to an example. The Bean name aware interface is implemented by beans that need access to its name defined in the Spring container. Now you might ask yourself, like, why would I need to know like the name of my bean? Well, this actually happened to me in real life on a project, and we weren't using Java, but it was using the .NET framework, and we used a process called reflection in order to get metadata of the objects. And that's what I had done in order to get the type of the object and also the name and some other details. And in our particular case here is to specifically do something similar, except instead of getting a bunch of extra data about an object, we're specifically looking for the name. Now, if you look in your exercise files, you'll see that we have aware interface underscore BN. And if we open up app.java, all I have here on line 9 is a sample bean object that we got from our context. And then on line 11, we attempt to display the name. If we jump to our XML file, we see where our sample bean is defined. And hopping right on over to samplebean.java, we see our variable for bean name, an empty constructor, and our method to display name. So if we try to run this right now, we'll get a null. We're not going to get the name of the object, but in order to get the name of our object, aka bean. We just need to go to line 3 and indicate that this class implements bean name aware. We'll add our import statement on line 3, and then all we need to do is create a method called set bean name. We'll pass in a string bean name, and then assign this dot bean name to bean name. And now if we run the project, in line 13 here, the parameter should actually be a smaller case bean name. And now if we run the project, we get the name of our bean, which is sample bean. I'd like to turn our attention now to the concept of bean scope. When you create a bean definition, what you're doing is making a recipe for creating actual instances of the class defined by that bean definition. The idea that a bean definition is a recipe is kind of important because it essentially means that just like a class, you can potentially have many object instances created from a single recipe. And you can control not only the various dependencies and configuration values that are to be plugged into an object, but also the scope of the objects. So let's take the first two examples in this chart here for singleton and prototype. If you wanted Spring to return the same bean instance each time one is needed, you should declare the bean scope attribute to be a singleton. An example of that is if you're building an application that's for an insurance policy. You'll likely be using just one insurance policy that's going to be modified in many different ways. So that policy object, that policy bean, should be a singleton. It does not need to change throughout the session. However, on the opposite end, if you wanted Spring to produce a new bean instance each time one is needed, you should declare that bean scope attribute to be prototype. If we're dealing with an application that has many different employees, each of those employees should be a separate bean. And so it makes sense to have the attribute be prototype. Now there are three other items here that we won't be going into detail. We actually won't be covering it at all because it's beyond the scope of this course. Request, session, and global session. Overall, the Spring Framework supports 5 scopes, and the last 3 are only available if you use the web-aware application context. But in our examples, we're going to take a look at singleton and prototype. All right, if you look in your exercise files, you should see a new project called singleton prototype. And if we open up the config file, you'll see that I have a simple bean definition for Rise and Shine, and its ID is RS. So if we hop over to Rise and Shine, you'll see that it's pretty straightforward. We have our Rise and Shine class, and then 2 things are going on. First, we create a setter method to set the value passed by user, and then create a getter method so that the user can get the set value. Moving on over to our app.java file, a few things going on here. Essentially what we're going to do is grab a couple of objects and compare them to see if they are the same. So first we get the bean object on line 12, and then on line 15 and 16 we set the name of the object and then print out a line that indicates the name, and we repeat the same for the second object on lines 19 and 21. Following that, we then compare the references to see whether they are pointing to the same object or if they are indeed different. And we do that on lines 25 and 26. And last but not least, we print out the addresses of both objects. Now, if you recall in the configuration file, we had set it up to be a singleton at first as the scope. So when we run it, we should see the same object twice. So let's execute that. And sure enough, first 2 lines says that your name is my object 1 from dev, and For the second object, it's exactly the same, my object 1 from dev. Following that, we check to see if they are indeed the same and the Boolean value is true. And last but not least, we look at the addresses of the objects and we see that they are identical. So that's the behavior of a singleton, but if we go ahead and change this to be prototype as the scope, that's really the only change that we're going to make here in our configuration file, and then execute the program. Now you'll see that the first object is my object 1, but the second one is null. And on the third line, we see that the Boolean value this time is false when comparing whether or not these two objects are identical, but also the addresses of these two objects are different, which is what's expected when we're using prototype because each instance should be a new object. Aspect-oriented programming, also known as AOP, complements object-oriented programming by providing another way of thinking about program structure. The key unit of modularity in object-oriented programming is the class, whereas with AOP, the unit of modularity is aspect. Aspects enable the modularization of concerns such as transaction management or logging that cut across multiple types and objects. These types of concerns are often termed as cross-cutting concerns in AOP. You can find more information here in the Spring documentation that goes really deep into some of the terminology and concepts of aspect-oriented programming, but I want to keep things simple and straightforward. In plain English, AOP is all about simplifying code and preventing code reuse. That is, it helps you conform to the DRY principle. Do not repeat yourself. And the way we'll demonstrate this is by providing an example of eliminating a cross-cutting concern. For example, let's say we're working on a system that has a payment service that's responsible for paying employees their paychecks. Now, this system can also have an email service that sends messages to these employees. Now, let's say these employees also travel, so there might be a travel service that keeps track of bookings for air flights. Now, these are all considered concerns. However, during the development process, one of the most important things that developers need to do is to troubleshoot issues that come up. And a common way that they do this is by keeping track of logs that gives you an idea of what state you're in during the process that the application is functioning. So logging, though, while it might be useful in one particular service, such as the payment service, it could also be useful in the email service as well as the travel service. So it's something that's very common that could be used across multiple services, and it's also considered a concern. But because it could be used multiple areas, it's considered a cross-cutting concern. Now, I use logging as an example, but there's other scenarios such as security. Code that's responsible for security could be used in multiple services. So security itself could be a cross-cutting concern, as well as transactions. So we're going to go ahead and use AOP in a way that will help us eliminate these cross-cutting concerns with a simplified example focusing strictly on the payment service. Notice in the Package Explorer that you have a new project called AOP. And this is a sample of the employee payment system that I mentioned earlier. Here's how it looks as of now. In our app config file, all we have is a bean specifically for the payment service, and of course the schema location and namespaces. In our payment service, we have two methods. One to pay the employee, where it just writes out that a payment has been sent, and the other is to clear the payment request, where it indicates that a payment request has been cleared. Next, we have our app file, which basically grabs the bean and then invokes both of those methods for paying the employee and clearing the request and passing in a sample employee, 2500. And why don't we go ahead and run it just to see exactly what happens. So as you would expect, it prints out these two statements, that the payment has been sent and the request was cleared. Okay, now in real life, a system like this can actually get very complicated, and the ability to log, to debug can be very useful, but the way in which we choose to implement logging is very important. So, for example, in the pay employee method, For debugging purposes, we may want to keep track of how things are right before we pay an employee and right after we pay them. So why don't we go ahead and write out a statement that simulates logging, entered, payment service, and I specify the namespace path along with the method pay employee. And right below, we enter a similar statement, except it's for exiting this method. We'll also do the same for clear pay request. Enter a statement that indicates we entered the method. The work gets done, and then we write out a statement that indicates that we exited this method. So let's save. And when we execute, we see the results with our logs. So it worked, but like I said, the way we log is important. And this approach is problematic because we shouldn't do this everywhere. This payment service is a concern, but the idea, the process of logging is also a concern. And because logging is a feature that could be reused elsewhere, it's considered a cross-cutting concern, just as I mentioned earlier. So to resolve this, let's start off by adding AOP dependencies that we need. Let's hop over to our POM file. I'll clear these results in the meanwhile. We're going to want what's called AspectJ, which is an AOP extension that promotes modularization of cross-cutting concerns. To use it, we'll need these two dependencies, the AspectJ Weaver, which is its compiler, and AspectJRT, which is the runtime library. Our next step is to move out our cross-cutting concerns, and we'll do this by creating a separate class, also known as an aspect, called log before and after. And before we do anything in this class here, let's go ahead and save this POM file that we just modified. And in our payment service, let's get rid of the log lines that we created. So we'll delete these. And back to log before and after class, we'll first indicate that this is going to be an aspect. And now we're ready to get some work done. There's a few things that we're going to do. In this file, we're going to define what needs to be done, when it needs to be done, and where it needs to be done. So addressing the what, well, what we want is to print a log message before and after every method in our payment service. And the log message will look written out like this. That's for before, and for after, a similar message. We'll add our imports. Now what we need to do is tell Spring which message needs to be executed before and which message needs to be executed after. And we do this by adding the annotation before and after. But the third thing is where. So we've addressed the what and the when, but now where. And to handle the where, we need to specify a point cut. And the syntax of a point cut looks like this, as I just added on line 8. And we'll do the same for line 13. Let's go ahead and add our imports for both of those lines. And just to clarify, a point cut is a predicate that matches joint points. And a joint point is simply a point during the execution of a program. This expression language may take a little to get used to, but essentially you can read it as we want to execute this aspect, also known as method, before execution of any method within the payment service. And the way I read this is exactly how you would read the following method for after. Now, one more thing I want to note is that Spring will send a joint point by which you can access the class name and method within these arguments. And it will end up writing out the statement similarly to how I had manually written out the log earlier on. Now, the last thing that we'll want to do is in our config file, we'll want to update our namespace and schema location. So we'll add the AOP namespace here on line 5 and our schema location right below the last line. Then we'll want to enable the functionality for AOP. And last but not least, define the bean that we added for log before and after. So let's go ahead and save this and execute the program. And ideally, we should have the same results as we had at the very beginning. Okay, and before we execute, I just noticed that there is a typo here. I want to fix log before and after to actually be spelt correctly. So let's go ahead and refactor log before and after. Okay, we'll save this. And now when we execute our program, we get the results that we had in the beginning. But this time we're using AOP, and we no longer have the cross-cutting concerns with the logging. Congratulations on making it this far. I hope you enjoyed the course. We've covered quite a bit of material. We started off with a deep explanation of what the Spring Framework was. We moved on to describing how to set up your environment, whether you're using Maven or individual jar files. We then moved on to discussions of IOC containers along with dependency injection and various Spring configurations. Then covered constructors and setter injection along with lifecycle and various different patterns. And last but not least, we wrapped things up with a discussion and demonstrations of aspect-oriented programming. If you'd like to follow me, go ahead and subscribe to my YouTube channel, and also feel free to follow me on Twitter at the links below. Thanks again, and I'll see you next time.